All right, let's look at this differential equation problem number 14. All right, it goes like this. Tank contains 1,000 gallons of solution consisting of 100 pounds of salt dissolved in water. Pure water is pumped into the tank at a rate of 5 gallons per second, and the mixture is pumped out at the same rate. Assume the mixture is kept uniform by stirring. A. Find the function that describes the amount of salt in the tank at time t. Alright, so let's do part A first. I'm going to let capital S of t be the amount of salt in the tank at time t. Right, so it's in pounds. All right, so let's set up a differential equation. Let's look at the rate of change of S of t. So with respect to time, so we look at the rate of change of the amount of salt with respect to time. All right, so all you really have to do is come up with this. We have to think about what would be the rate of salt coming in. So I'm going to just call it rate in. And then we have to subtract rate out. Right, so here is the rate out. Right, so how fast the salt is going out of the tank. All right, so since the pure water is poured in, so it said somewhere, let's see, pure water, here, pure water is pumped into the tank, which means that there is no new salt introduced into the tank. So rate in would be actually just 0, since it's pure water is pumped into. All right, then we have to think about how fast is the salt going out of the tank. All right, the solution is going out at the rate of 5 gallons per second, and we have to think about how much salt that solution contains. All right, so since at the time t, S of t, the amount of salt, all right, then since the rate in and the rate out, they're going in and out at the same rate, so the tank always have 1,000 gallons of solution in there. All right, so concentration of salt of the solution at time t would be S pounds per 1,000 gallon. So I'll just do that. All right. Then we're letting it out at the rate of 5 gallons per second. So we multiply by 5 gallons per second. All right. So which means that, let's see, we can cancel 5 and 1,000. That gives you a 200 on the bottom. So this is going to give us S over 200, right, pounds per second. Right, so that will be the rate out. So I'm going to put the S over 200. All right, so we got that. Then what we're going to do is we just have to solve this differential equation. Right, this equation is actually a separable equation. So I'm going to just say separable equation. All right, so we just have to separate the variables. All right, what we're going to do is I'm going to actually divide through by S. So you have 1 over S and ds over dt is equal to negative 1 over 200 because we divide by S. All right. Then we can integrate both sides with respect to time. right, with respect to time. Right, so we can simplify. So dt on top, dt on the bottom cancel out. So this is just the antiderivative of 1 over s, which is natural log of absolute value of s. Right, absolute value, we don't have to worry too much about absolute value because we're not going to talk about the negative amount of salt. All right, and here antiderivative a number, negative 1 over 200 is negative t over 200, right? And then I'm going to say plus some constant c. I'm going to call it, let's call it c1. All right, then we can just raise e to both sides of the equation. We get e to the natural log of absolute value of s is equal to e to the negative t over 200 plus c1, right, which can be rewritten as e to the negative t over 200 times e to the c1. All right, and you can see that I'm going to actually call e to the c1 is still a constant, so I'm going to call it just a c. All right, so we have, right, I'm going to actually get rid of the absolute value sign, and we have exponential function and log function cancel out because they are inverse of each other. So you have s, function s is going to be some constant c, and then you have e to the negative t over 200, right? Then another thing we need to use is that initially it contains 100 pounds of salt, which means that so amount of salt at time 0 is going to be 100 pounds. So we can use that initial condition to find the value of c, right? So let's do that. Let's plug in s of 0. So f of 0, so t is 0, right? You have c. Right, e to the 0th power is 1, so it's just going to be c. So we know that this has to be equal to 100 pounds. Right, so therefore we have s of t. Right, so this is the amount of salt function, and the c came out to be 100. And then you have e to the negative t over 200. Right, so this is the function we're looking for. So this is the function s of t. Right, so this is part A, and part B. What we want to do is we want to use that, and how long will it take until the amount of salt dissolved in water reaches 2 pounds? All right, so we just have to set s of t, which we just found. Is 100 e to the negative t over 200, and we're going to set that equal to 2, right, because we want the 2 pounds, right? Then let's solve for t. So first I'm going to divide through by 100, so you have e to the negative t over 200, which is equal to 2 divided by 100 is 1 over 50. Right? Then we can just simply take the natural log of both sides. So you have a natural log of e to the negative t over 200 is going to be natural log of 1 over 50. Right? If you want, this is reciprocal, so it's a negative 1 power, which can be placed in front. It's a natural log of 50. A negative natural log of 50. All right, then you can see that log and the exponential function cancel out. So you get that a negative t over 200 is equal to negative natural log of 50. So what you can do is you can multiply both sides by negative 200. So that way we get the t is equal to, right, negative cancel out, and you have a 200 and a natural log of 50. Right, this is in second. Right, maybe I should say second. right? If you compute that, this is about, if you approximate it on a calculator or something, right, maybe I'll bring out the calculator.